Thank you very much for coming. Just going to say a few words about myself. So my name is Johannes. I live in Cork. I've been developing in Python since 2002. I'm not quite sure, that's a long time ago. And so I've built large-scale machine learning solutions with Python, TensorFlow, Kafka, and Spark. My company is Sensatus, and we do on-premise AI models and web scraping and gathering data. And I will be putting up the code for this talk on GitHub, but it's not there yet, so don't look. But but it will be there. So actually, let me send that. So I'm not a very structured person, so I'm very happy for you, as you will see. So I'm very happy for you to ask questions at any point, and we might go off on a tangent. But I guess the most important thing is that you take something away from the talk, and happy to make that more interactive. So in terms of machine learning, I've been instructed to stay on this side, so it's nothing against you. It's just the instructions. So in machine learning, we have, and it's a little bit complicated, it's a little bit more complicated than this looks, but basically we have supervised learning, reinforcement learning, and unsupervised learning. And so a couple of challenges. If we're doing reinforcement learning, so OpenAI are doing it, and a couple of groups are doing it. But generally, with reinforcement learning, you need an interactive environment. And so that, depending on the setting, that can be quite difficult. So if you have a self-driving car, it's not quite clear what an interactive environment looks like. So it could be a computer game, or you might have to put a car on a road and let the reinforcement learning start from there. With unsupervised learning, it can be hard to validate and to guide the unsupervised learning. So, for example, recently there was the GPT-2 text generation. And the question is, if you have a question answering system, how do you evaluate whether the answer is good or not? Like, that's not an easy answer. It's not an easy question to answer, right? So if you have something that generates lots of text or lots of clusters, how do you figure out if there's any value in the text or in the clusters? So today, in the talk today, we're very much going to focus on supervised learning. It's the easiest, and in a way also a little bit boring, because a lot of the excitement is happening in reinforcement and unsupervised. But I think there's still a lot to be done in supervised learning. So if we're talking about supervised learning, we're talking about things like natural language processing. There's a lot of supervision there. Speech to text, there's a lot of supervision there. In machine vision, if we're classifying, there's a lot of supervision. And then we also have some other things like semi-supervised learning and embeddings, which kind of don't fit well into those categories. But the general idea is, if we're doing supervised learning, we usually have a data set that has the correct answer annotated. So whether it's a classification or a regression, we have a probably quite large data set, and we know what the correct answer is. And then we can use machine learning to train the model on that. And the question is, do we need training data? Like, if you're going to Amazon and to Google and to IBM, they will say, oh, look, we have all these models. You don't have to care about anything. You just put your data in. We give you the answer. You don't have to worry. And likewise, if you're going to GitHub, probably most of you here, like, who has been using a pre-trained model? Okay. But so there's a lot of convenience of using pre-trained models. So where somebody has run 100 GPUs for 6 months and hopefully it does something. But the problem is, with the pre-trained model, it doesn't always work. So like, one thing is that, for example, speech to text, there's a lot of challenges with pre-trained models. Even Google and all the FANG stocks, they're still having trouble with accuracy for speech to text. Like, we're still somewhere 70, 80, 90% accuracy, which is actually not great if you want to make decision based on that. So one thing is, if you want to customize a model or want to do transfer learning, you need some sort of training data. So you need access to the pre-trained model, and then you need access to training data that you want to use to customize, to adapt the model more to your needs. We also have generic models or use case specific models. So, and I guess I did have, yeah, so for example, in speech to text, we have accents, we have dialects, we have jargon, and then also we have constrained contexts. So let's say the Google speech to text is trained on anything, but if what you want to do is transcribe call center calls, they are very, very constrained in context. So then it doesn't help you that the model can understand everything about the Serengeti and space and child rearing if all you're doing is having a call about renewing an insurance policy. So those are cases where the pre-trained model is probably too generic and too broad, and you want to go closer. You want to go more specific. And likewise, when we're talking about sentiment analysis, there's lots of differences culturally. So if you're talking to somebody from Spain or France or South America or Sweden, tone of voice, choice of words, like what's culturally accepted, all of that is not, there isn't always a correct answer. And even human to human, we get things wrong. Like you might talk to somebody and say, why are you so angry at me? And they go, I'm not angry. This is how I always talk. I hope I'm not that person. And then also, a lot of NLP pre-trained libraries, they focus on a very small number of languages. So basically it's, if you're very lucky, it's English, Spanish, French, German, and maybe Chinese. And that's usually where it ends. Like Polyglot, they support a couple more languages, but chances are the language that you need is actually not supported. Like if some do Arabic, but basically if you want to do Japanese, I've not seen a lot for. Portuguese, I've not seen a lot for. So those are big markets where pre-trained models may or may not exist. So Google has something, so they even do Irish, but that we don't have access to that. So I'm going to go through a couple of, are you okay to see that? Yeah. I'm going to go through a couple of Jupyter notebooks and show some of the data that's available. And very happy. Are there any questions up to this point? No. OK. So the first one that I wanted to show you was Google BigQuery. So they have, this is called Bigtable, I think. They released a paper a long time ago about how to do fast queries on very large data. And what they've actually done is they've made that available for public use. And so I'm not going to go through all of that. But basically, there's quite a few data sets that are on Google BigQuery that we can query. So if you sign up, where did the information go? There. So they give you 1 terabyte of queries free per month. So so the terabyte means how much data did BigQuery have to process to give you the answer to your query. And so I think a terabyte is pretty generous. And also, if you sign up with BigQuery, you get $300 of free credit, at least when I last checked. So basically, so there's lots of data sets on there, but I'm just going to focus on kind of the social media type ones. So just in terms of the Python, there's actually not much to be done. There's a very good library. There's actually 2 libraries, but there's a very good library. It's called BigQuery, and then we just get a client and pass in our credentials, and then we send a query in, and then we return the results for that query. So it couldn't be much simpler. If you're doing very large queries, so if you're going into that terabyte range, the queries will take longer than 30 seconds or 60 seconds, and then you'll have to deal with timeouts and stuff like that. So then you'll have to do an async query where you send a job, and then you poll whether the job has been completed. So I've put the code here just if you want to look at it after the talk. But for small queries, also all the examples here, they're all done with the synchronous ones. So if we take, for example, there's a Reddit data set, so what we can do is everybody able to see that okay? Can make it even bigger and bigger. No, can't. So what we can do is we say we want to go and go into the Reddit dataset, and we want to go into one specific subreddit. So in this case, the subreddit is our videos. And we want to get all of the posts that contain YouTube links. Yeah, and actually this was for July 2018, so I haven't updated that. And then what we get back after, I'm not going to run it. These are all live, and I ran them a while ago, but I can't connect to the Wi-Fi, so it's just going to all go away. So, so then what we get back is all of these links, all of these posts that have some sort of YouTube link in them. So I've used that to go through our videos on a daily basis, look at the YouTube videos that I mentioned, go to the YouTube API that I'm going to mention later, and get all of the related videos to those, and then build like a recommendation engine on that. But you can see, like with, I don't know how much was that, 6 lines of code, we're able to go over all of Reddit and look at, yeah, we can filter, we can search, we can do all kinds of cool things. So we can build a social graph of who's responding to whom, who's most active in which subreddits have the most traffic. All of that we do just with a SQL-ish query. So anything that you could imagine on top of the Reddit graph, you can do on BigQuery. And if you're staying under the 1 terabyte, then that's completely free. And also the other thing is you don't have to go over all of the data, because if you've processed the last 12 months, in a month from now, it's probably sufficient to just process the last month and then combine the data. Any questions on that? Yeah.
Just, it looks like it took a few iterations, let's say, to get to that SQL query.
Yeah. So BigQuery, they have a really good, I think I closed the window, but they have a really good interface where they give you a preview, they give you the schema, and they give you an interactive query editor. So there isn't any like 20 hours of trying to get it to work. So the BigQuery interactive tool works incredibly well. So the only thing is, because the queries, they're batched or something, it always takes like a minimum of 3 seconds to tell you that you have a typo. But I think that's, if you're doing terabyte processing, I think we can probably live with that. Any other questions? Yeah.
Yeah, I've never used BigQuery, but is this notebook running from your local machine, or is this one of those Google collaboratory?
This is a local one. Yeah.
Yeah, I had a friend who was using BigQuery, and he said you should always add a limit, or else you.
Yeah. I have that here. It says this query ignores limit request. So depending on how the data is set up and what you're querying for, so in some cases you have to do a scan, and then that's quite expensive. But a terabyte is also quite a lot. So most of the data sets, they're less than a terabyte, so at least you can do 1 query per month. No, but and also the pricing, the non-free pricing is very reasonable. So I think it's $5 per terabyte or something like that. I don't know what it was, but it's not incredible amounts of money. Any other questions? Okay. So then I'm just going to go through a couple of these, and from the Python side, they're all the same. So there's a project called Github Archive, and what they do is GitHub have an API, and on the API they stream every request that's going to GitHub. So if somebody's doing a commit, not a commit, somebody's doing a push, opens an issue, merge request is merged, pull request is merged. Every one of those is an action in the GitHub stream. And GitHub Archive, they've archived everything. So this does not apply. I don't actually know how it works for private repositories, but there's some information that's not in here regarding private repositories, but everything regarding public repositories is there. So what you can do then, and that the GitHub Archive information is on BigQuery. So then what you can say is, you can say, give me each contributor and each repository for a specific date, where the type is watch event. So watch event is when somebody stars a repository and says, I like this repository, and I press the star. That's a watch event. And so then we have a limit of 50 here, or 10 in this case. And so it shows here the user Si Bueno starred the repository, this one, detective. And so what you can do then is you can do this over all of GitHub history, and you can generate all kinds of visualizations, because let's say you have a repo that has 15,000 likes, but maybe those likes happened 3 years ago or 5 years ago. So you can actually, and I've actually done that to get the entire star history from GitHub and put it into a graph database, and then you can do recommendation engines and so on. So based on my star ratings, what other repositories have other people who have starred similar ones also starred? So this one is a lot less interesting, but it's like these are, I don't even know what that's sorted by. Oh yeah, it's by created date. So these are the last the last projects that I've star rated. So that's my GitHub username, and that's the repo name there. But you can also find similar users. So you can have a recommendation engine for what projects would be interesting, but you can also say what other users are doing something similar to you. So I think there's a lot that can be done there. Any questions on that so far? So another project that I think is very interesting is GDELT. I don't actually know what that stands for, but so it's a project, and what they've done is they are scraping, I don't know, hundreds or thousands of news organizations in a real-time basis. And so they capture news articles, newspaper, and any kind of news material. And then this is also on BigQuery. And what you can say is, so the query here is, give me the actor 1, actor 2, and the source URL from GDELT for the months of September 2019, where actor 1 is the Irish government. And so what this means is, GDELT, they take news articles and they do named entity recognition on it, and they turn it into triples, or triples, I guess, where it says actor 1 did something to actor 2, and it has multiple of those triples, so it's an information extraction. And so then in these, what you can see here is we have all these news articles on the right. We see that the Irish government is doing something with firefighters, the Irish government is doing something with the US military, the Irish government is doing something with Cyprus, and then we have the average sentiment tone. So I'm not a huge believer in document sentiment, because I don't think documents generally have a sentiment, but I guess you can tell that, I guess if the firefighters and it has a positive average tone, I guess it's something where somebody got a medal or an award or something. So I think that's really cool. And then what you can also do, I picked one of these articles and I said, give me the same fields, but this time limited to one source URL. And so it gives me all of the actors that were extracted from this one URL. So it's not displayed very well. But so it's all the same URL, but these are different actors that have been extracted. So I guess the Catholic Church appears in this article, the Irish government, the French, the Premier, that might be Vratgar, Belgium appears in here. So this could be used as a starting place for generating training data for entity extraction. So because you have the source article and you have all of the entities that GDELT have extracted, that would probably be a pretty decent starting place to do named entity recognition. Any questions so far? Is that making sense or not so much sense? Okay, cool. So then, and I'll go through these because they're all kind of a similar vein. So there's also a Stackoverflow dataset. I think they do it every quarter, where you can say, give me all Stack Overflow posts that have happened in the last quarter, and then it shows the text of them. So again, we can build a social graph. We can say who's very active, who responds a lot, who posts the most, in which Stack Overflow topics, etc. There's also a really cool one, and I didn't actually know this until today, that so there's a website called libraries.io. It's actually quite nice. And they're looking at all open source libraries in different languages, and they're tracking which projects are depending on which other projects, Yeah. So what you can do is you can say select all the projects and the dependencies from PyPy, so the Python organization, and then it says here we have project latex build depends on Ginger greater equal 2.8, etc. And again, we can build a social graph from that and say what are the libraries that are being used particularly much and in what versions, etc. So I think BigQuery is pretty cool. You can obviously also upload your own data sets. So if you have a massive data set and don't want the hassle of processing it, you can also upload it there and then process it. So I'll move on from that. Any questions on that? Okay. So the next one that I think is actually really cool is Twitter. So Twitter, they have a public API, and they have a very cool limit. So you can stream all of Twitter, but you can't stream more than 1/6 of the tweets, which I think is pretty reasonable for a free API. So you can stream up to 1/6 of all Twitter traffic in real time on this. So you have to sign up for an API. One point that I didn't mention was if you're going through an API, there's almost certainly a license agreement that you're undergoing. So in GitHub and Twitter, etc., they all say you can't use this for commercially, you can't use this to contact people, etc. So I don't quite know how that would play out if you use a data set for machine learning and if the model, if the provenance of that data is in there, but I think that's something worth thinking about. And then if you don't want to be bound by that, maybe there's other ways of getting that information. But I think just to get started, this is a fantastic source. So with Twitter, there's a very good library for Python. You just create a new stream. So this is for the live streaming, where you say, I want to get all the tweets as they come in. This is very complicated. So basically, I'm giving a couple of keywords that I want to search, and then I'm just. So I'll show you in a moment. So for an example, I want to have all of the tweets that are using these terms. So some of those are hashtags, some of those are just general machine learning terms. And so what I'm doing is I'm passing those terms. Where is it? Somewhere. Stream, compile. Here. So I'm passing those terms to Twitter to say I'm only interested in tweets that match these terms. But sometimes Twitter, I don't know, they send you back random stuff. So I also have a regular expression to double check what I'm getting back, because sometimes there's stuff that I haven't figured out why it is there. And also you can filter by language. So I was just interested at the time in English tweets. And so then if we take these machine learning terms and we run get tweets and we take the first 10 of them, then, so this is what one tweet looks like. It's actually surprisingly verbose. So there's a lot of information in here. So about the user who tweeted it. So this is a single tweet that we're looking at. Where geographically they were, what entities they mentioned, etc. So then if we look at the matched tweets, there's also a difference between the old tweet, which was 140 characters, and the new tweet, which is 280, which makes it harder for us poor programmers. But basically what we can do is, these are the last 10 people who said anything about machine learning on Twitter. So this is as of, half an hour ago. So we have the Twitter user and what they wrote. And so something where I've used this before was, I took the tweets for a particular subject, I did sentiment analysis on them, and sorted them whether the author had a lot of followers. And so then what you can do for your topic of interest is you can follow the ones, for example, that are particularly negative and use that as an entry point to join a conversation. So if you're in a sales function, you can say the product or the space where I'm selling into, show me all the tweets that are extremely negative, and then you can go and, oh yeah, have you looked at our solution? Obviously in an ethical way. But no, but I do mean that. But I think it's if what you're saying is relevant rather than spam, I think that's fair enough. Yeah.
Just 1/6
No, so you get all the tweets on machine learning, but it's capped at 1/6 of the total.
Okay.
So
you're getting a sample of the population of tweets on machine learning.
no, I think, well, I don't think there's a guarantee that you're getting all because, distributed systems and all that. But if your query is reasonably small, then you get then you get everything for that query.
Okay.
It's just if your query is empty, you can't get more than 1/6.
You can't put all into a query.
Yeah. So there are ways. There's some companies who give you access to Firehose, Twitter Firehose, but I think that's a different issue. Yeah. So and obviously you can do that with lots of things. So then we can also do. So I wanted to find everything on machine learning, but I didn't know what I wanted to search for. So then what you can do is you can start somewhere and say, show me everything for these relevant hashtags or topics, and then I don't know how. I don't know. I don't think I have time to go through the Python. I'll put it up on the GitHub. And then I can say, do a sorting of all the other hashtags that came up in relation to the hashtags that I was looking for. And then you can kind of iteratively find additional hashtags when, completely forgot that one. So in this case, we have artificial intelligence, fintech, blockchain, robotics, IoT, NLP, digital transformation. So then you can kind of find a way of exploring more what other people are saying together with this. And also, in some cases, you get something completely stupid where you then go, oh crap, I had a keyword that was too generic. And then one particular use case that I really like is to use, there's a library called Deepmoji or Deep Emoji, which if you give it a text, it will give you the emojis that should go with that text. Which sounds like really stupid and useless, but actually I don't think it's useless at all, because if you're doing sentiment analysis and you have polarity, I think polarity is actually what's really useless, because you could be angry or sad or disappointed or depressed, and those are not all the same thing. Whereas if you have a good training set based on Twitter, so what I did is I took a couple of emojis and I said, give me all the tweets with these emojis. And so then this is what I got back. So there's like 100 of them here. So this one says, boss fans are with you. And then it's smiley, heart, muscle, fire. And so then what you can do is, I don't know. And then what you can do is to say, which emojis appeared a lot together with those emojis. And then you can use this. So this one here, you can use straight up as the classification training set. So you just let this run for, I don't know, a day or a week, and then you have 10,000, 100,000, a million rows where you have a text and you have emojis that went with the text. So what I did was I took the text and removed the emojis, and then I removed them, and so I split them apart. So now you can just run a classifier on this. So in this case, it's a multi-label classifier because you can have more than one emoji per text. But so, there's not much work involved. So then you have to find the good features and representation and so on. But you can now have all the data that you could need. And you could actually specify this to your group of people. So maybe you want to do it for Instagram people or machine learning people, and they will use emojis differently. So then you actually can have different data sets where the poop emoji means different things to different people, I guess. And then I guess there was a really cool project that I came across that there's some, I'm not really an emoji person, but there's some emojis that are used in kind of creative ways, like the eggplant and the, so you can also figure that out, because we have all the training data to see what embeddings or what keywords go together with certain emojis. And then you can make that, for example, in Hong Kong right now, they probably have some emojis that's very specific to that setting. And a lot of that would happen on Twitter. Any questions on that? Yes?
So you mentioned this is not for commercial use, this API.
Yeah.
If you cannot use it for commercial use, is it just for your personal hobby activities? What can you use it for?
So I'm not a lawyer. So So what the big companies, what they do is they go, oh, we anonymize the data, so that's why it's fine. So you could just do the same and just not use the username and remove a couple of, I don't know. So I don't know, like in Germany there's a saying, there's probably a saying in English as well, that where there's no accuser, there's no jury. So if you use this data to create a model that can predict emojis from text, it's probably quite difficult to prove that, or I don't know. I don't have the answer. Like, we're just all here for fun.
So you told the judge.
Yeah, that's a no, but there are, there are other ways that you could go about it, and there might be, I don't know. So, for example, a good example is Venmo. They made the great decision that every traffic on Venmo is public. So Venmo is an app to send money from one person to another. And so they made this brilliant idea that why don't we make everything public from the get-go. So you have there's this website, I don't know what the name of it is, and it has these massive stories of where the drug dealer talks to the drug addict and goes, why aren't you paying me? And so I don't know what they're No, it's a very good website. But I don't know what their license is, but seeing how they put everything public, they mightn't even have a license. So that might be an alternative. Running out of time. So the next one that I think is really cool is YouTube have an API, and they give you 1 million requests per day, I think. But then I didn't use it enough, and they cut me down to 300,000 per day. So that was a very sad day. But basically, there's a client from Google themselves. So they have this Google super client that can do anything on the Google platform. Again, I can't really go into all the Python code. But basically, you can do all kinds of things. You can search for channels, you can search for videos. On the video, you can go through all the comments, you can get all the subtitles for a video, you can get the related videos for a video and stuff like that. So what I've been doing is I've been going through the Reddit R videos and the top videos on YouTube and got 50 related videos for all of those to build a graph of videos that might be interesting, and they are also categorized by pretty fine detailed categories, so you can also say, oh, I'm only interested in drama or something like that. So what you can do is you can say, I want to see all videos that are related to machine learning. I want to get 200 of them, and then this is the information that you get back. So there's the video ID, when was it published, the title, the description, all the different thumbnails in different sizes, what the channel was that put it out, the tags. These are some this is some ontology topics. I think the topic quality is really low, but I guess it's a starting place. So this one is lifestyle and knowledge. And then what you can also do is you can pull all of the comments for that video. So then you can see who commented, the author, etc., etc. So one place where I think this is quite interesting, and it comes back to the licensing and the use restrictions, that you can. I don't think the API allows you to pull the video itself, but you can get that directly, but it does allow you to get the captions. So they have computer-generated captions, which are actually really good. And they also, in some videos, have manually generated captions, and they are time-stamped. So if you pull down the video and you pull down the time-stamped captions, you have a fantastic training set for probably more speech-to-text. You have a really good training set for speech-to-text, and you can make it specific. So if you're working with a company who want to transcribe phone calls, see if you can find videos from Donegal or from Galway or from Belfast, and then you can have basically as many videos as you want that are all captioned. So I think that's a really interesting space. And also, again, we have that whole social graph of who's posting, what channels are closely related to each other, and so on. So the next one is Common Crawl. So Common Crawl is an initiative. They are crawling the web, and I think it's a non-for-profit. And so it's difficult to kind of keep up with the numbers because they do a crawl every month or something like that. But in total, they've crawled about 250 terabytes and 3 billion web pages. So apparently that's not the entire internet anymore. So it's like a super small chunk. It's like 5% or something. But and one thing that's really cool is they've also created a PageRank for the top 112 million domains. So that's actually quite an interesting one. If you want to do web crawling, at least you have a starting place with 112 million domains. So what you can do here is we can, so the Common Crawl data, it's all hosted on Amazon Open Datasets. So in my case here, I've actually pulled one of the files and went through it. But like a much smarter way is to actually run that on AWS as EC2. And you can actually run through the whole of it it's your choice how quick you do it, but like for a very reasonable amount of money. So I've seen people do it for, I don't know, whatever, $10 or $5 to go through everything and pull out whatever you want to pull out. So in this case, what we've done here, we have a file. So this is one of the crawl files. We're fetching the file, we're parsing it, and then we're extracting social media links. And for some reason, everybody is putting Google Maps links on their websites these days. So every company, if you go to their website, at the bottom, you'll find a Google Maps link. So that's very useful. So this is kind of the output from that. So what we have here is we have a URL that Common Crawl had crawled. These are the social media links that we found. So there's a Oregon Wine Press Facebook, there's an Oregon Wine Press Twitter, there's an Oregon Wine Press Instagram, and there is this Google Maps link here, which looks a bit shit. Like Google Maps, they have crazy URLs. Let me see if I can find a nicer one. Yeah, so this one is quite nice. So this one here, this is a lat long encoding. So I think it's 39 lat and -8 long or something like that. So now you can go over all of the 3 billion websites that Common Crawl have gone through and connect the Twitter handle, Facebook handle, Instagram handle with the lat long of where that business or organization is based, which is actually quite neat. And then for scaling, you can do a lot of crazy stuff on AWS. There's a library called PyRen, but I'm struggling with serverless stuff, so I haven't actually done that yet, but it's on my to-do list. Any questions on that? Okay, so I don't know what the Common Crawl, they can't license it because it's not their stuff in the first place. So I don't know what the license restrictions there are. I'd have to ask a lawyer. The next one is Wikipedia. So there's a lot of stuff on Wikipedia. There's some old projects that are now defunct, like there was Yago, which built on top of Wikipedia. There's DBpedia, so lots of different things. But I think one thing that's really interesting is this DBpedia as tables. So they've taken all of the Wikipedia structured content and put it into JSON tables. And so you can just pull down let's say the list of all universities. So there's 20,000 universities on Wikipedia. And you can just go through it and you can say, okay, give me all the information on University College Cork, UCC. And then it says, okay, it's this is the president, this is the country it's in, this is the city it's in, these are the labels of it, etc. So like there's a lot of information here, and each of those are entity that you could then dereference as well. So it has what kind of an organization is it? It has 762 faculty, 3,000 postgrad students, 12,000 undergrad students, etc. So I think that's pretty cool. And the same thing exists for companies. Obviously, it's a very 67,000 website, 67,000 companies. Obviously, very, very small sample. Most of them are like blue chip, etc. but you have the same, you know, like who are on the board of directors, who's the CEO, how many employees do they have, what's their website, etc. So there's a lot. So what they have on Wikipedia, on the top right of the Wikipedia site, they have an info box, and the info box is actually structured information. So anything that's in that info box, you can query incredibly well. So there's no parsing and guessing involved here. So all of that data, I think today, it lives underneath the Wikidata organization, but you can pull, you know, authors or anything that's on Wikipedia and that has an info box, you can query. And then, is this the last one? Yeah. And then the last one is Geo Names. So Geo Names is a database. It has 10 million geographical names. So basically any village that has more than 100 inhabitants is in that catalog. And it has all of that hierarchically organized. So it says what's the parish, what's the county, what's the state, what's the country, what's the lat long, what's the number of inhabitants, etc. So what we can say is we can say, give me the list of all the cities that you have, and then there's just cities, there's Unicode versus ASCII, alternative names, the lat long, and then all kinds of categorization. So there's 134,000 cities in there. And then you can say, give me all of the cities that are called Dublin. So apparently there's quite a few of them. Again, with the lat long. And so then what you can do is to get all of the information about Dublin, Ireland. So this is actually the Geo Names database. You can actually download and do it locally. It's not huge, but it's a little bit of a pain to get it going. So there's a free API that this geocoder library actually uses. So then you don't have the hassle of hosting it yourself. And then it has all this information where it is. So, and then one thing you can do, for example, is you can, so this is the stupid way of doing it. So because usually what you do is you'd have a geocoding enabled database, and that would do this all in a sane way. But what I did was I just said, give me the lat long for Dublin, and then give me the 10 closest cities by distance, Euclidean distance. And so then it comes up with, so these are according to Geo Names, these are the 10 closest cities, villages, whatever you want to call them. So Rathmines, Sandymount, Donnybrook, etc. So I think that's, you can probably do quite a lot with that as well. So that's kind of the end of my talk. 10 minutes, okay. So I guess just to wrap it up a little bit. So actually there's one more thing that I wanted to show. So one thing that I've done in the past was I was very interested in or obsessed with cryptocurrencies. And so there's two forums that were quite interesting. There's a Reddit one called, I don't know, cryptocurrency, and there's the Bitcoin forum. And so there's actually a lot of traffic on those forums. And what I wanted to do was to say, I want to know what the sentiment is that is being talked about. So this is kind of going more into the web scraping. So this is not an API as much. But if you web scrape something like Bitcoin talk or Reddit, actually on Reddit it's actually an API. So I did actually use the Reddit API directly. And so what I did was I filtered out all of the crypto tokens that were being talked about, how many mentions were there per token. So like there were, I don't know, 2,300 people talked about Vertcoin. And then how much it had already appreciated. So if people were talking really positively about something that had just gone up in price, that's obviously not very interesting. And then the 8-week sentiment and the 16-week sentiment. And the reason I picked those was that a lot of the pump and dump schemes, they don't have the patience. So 16 weeks is a pretty long time horizon to say, you know, if people were talking positively, how much is that, 4 months ago, and they're talking positively in the last 2 months, then I don't know. And it hasn't gone up in that time frame. So so then you could see here that, I don't know, So the validity and the point of doing this is highly questionable, but it can be done, and with Python. So so for example, here you have like let me see one that was good. So for example, 0x, the 4 months was a positivity, the sentiment of +2. 2 months was a positivity of, sentiment of +4. So the sentiment had improved. It had only gone up 10% at this point, and then actually it ended up going like through the roof. So again, it's probably kind of outside of the topic of the talk, but so with the Reddit API, with the Google BigQuery of the actual Reddit historical stuff, there's a lot you can do. And you probably heard about GPT-2 that OpenAI created. So they actually based that on a pretty significant web crawl. What they did was they went to Reddit and they pulled every hyperlink out of Reddit where the post had like a rating of +2 or karma or whatever. So they went through all of Reddit, took all of the hyperlinks, and scraped all of those, and that's what they used to train GPT-2. And so there's a couple of people who've recreated that and have released a pre-trained model for GPT-2. So in the combination, I think, of open APIs and scraping, there's a lot that you can do.